Mainly two types of operations can be performed: transformations, actions. Observe here, transformations, if you are performing an RTD, the result is also an RTD. Spark object we call RTD, right? Spark data object. Transformation on RTD, the result also an RTD. Transformation, here the transformation can be what? Filtering the data, transforming the data, merging the data, grouping or sorting. Whenever you perform any action on RTD, results a local object, means Python object, you want to get a Spark object. We have got transformations and actions every time. Observe, if you perform transformation, the result is an RTD. Action results a Python object. Transformations, three types. Transformations, three types. Each element transformation, example by using the functions like map and flat map. Each element means if we got 1 lakh employees, each employee name first character to be in the uppercase. So each and every employee, this is going to be applied. Filter transformation, filtering based on condition. Aggregated transformation means like grouping, group by key, reduce by key, group by city, group by department number. Mainly these three transformations, right? Actions. When an action is performed on a RTD, then only the data flow will be executed from the root RTD. If you see a diagram, right, flow data flow, the entire data flow will be executed only when we perform an action. The following are some of the actions: collect, count, take. Collect means it collects all the partitions which are distributed across multiple RAMs of multiple systems into client machine. RTD.collect. Count counts the number of elements of an RTD. RTD.count. Take takes first 10 elements of a RTD. RTD.take of 10 means takes the first 10 records. If the partition is having only 5 records, it takes 5 from partition 1, 5 from partition 2. Save as text file for storing the results into HDFS file. Okay, so these are some actions I'll be discussing practically, right? One by one action and transformations. But first, how an RTD gets created. You got one HDFS file path, Hadoop distributed file system. So just the file path. If you are loading that file using Spark sc.text file, Spark context.text file, right? Yes. Whenever you are loading that path, RTD1 is created. From RTD1, if I apply some mapping operation, so map each element to start with uppercase, the result what you get is RTD2. On that RTD2, again, if you perform any filtering operations, RTD3 created. On that RTD3, again, some map or flat map, RTD4. And again on RTD4, some grouping operations, RTD5. Finally, this is a data flow. On the RTD5, I am performing an action like collect. What is RES here? Is it a Spark or Python object?
Python object.
Python object, right? Whenever action perform, Python object. Whenever transformations, map, filter, all these are transformation. Then
So what is that SC? There?
Spark context. Spark context. Using that Spark context, if you are loading a file, then RTD creates. Using Spark context.
How do we get to know that? So what are the methods are in action actually? So is there any way to be see in that editor or somewhere else?
What are that?
What are the methods are functions are action actually? Like here, collect is in action.
I'll discuss one by one action with practical, right? Practically, I'll show you one by one action, one by one transformation.
Can you also cover the architecture you have covered? I missed one class. I don't know whether you covered that Spark architecture or...
No, I'll be discussing it.
Okay. Because this Spark context, I'm not able to remember it actually.
In the practical part, I'll be discussing that.
Okay. Okay.
Currently, how many RTDs? 5 RTDs. How many RTDs in the RAM means 0 RTDs. Why? When action is performed only, when you perform action only, then 1 by 1 RTD will be loaded and computed, and the previous RTD gets removed. Once the execution is completed, last RTD also gets removed. So yes, I said about persist, right? Whenever you persist an RTD, that RTD remains in the RAM and gives output to the other flows. Means that RTD won't be removed even though the next RTD is ready. How to persist an RTD means 2 ways to persist an RTD. RTD.persist, RTD.catch. So about persist, where you want to persist in the memory, in the RAM, or in disk, or memory or disk. If memory available in memory, otherwise in disk. The 3 options. For this, it won't support all the 3. Only one, only in memory only. This memory or disk or memory and disk both. 3. 2 ways to persist an RTD. So whenever you persist an RTD, that RTD will be available in the RAM. But if total execution finished, now you doesn't want it. If you want, you can unpersist it forcefully. Or when session closes, it unpersist. Or when server shutdowns, it unpersist. 2 situations where RTD will be removed from the RAM means when the next RTD is ready, the previous one will be removed. When action is completed, the last RTD gets removed. 3 ways to unpersist an RTD. Forcefully unpersisting by saving RTD.unpersist. When session is closed, when server shutdowns.
Sir, one question. So when we persist the RDD in the disk, then how do we get that while processing to RAM? Because while processing, we process in the memory. So is there any function or something that we bring that RDD to memory?
Okay, how will you know whether it is persisted in the RAM, whether it is persisted in disk?
Yeah, no, I'm not sure. So there are 2 methods, as you said, that we can persist into the memory or to the disk. So if it is in the disk, then we have to bring that to memory. So is that correct?
So when you are trying to persist in the RAM, already the RAM is busy with the other RTDs.
Okay.
Other RTDs are getting computed. But now if you are persisting, there is no space in the RAM. Then in such case, the execution phase, instead of failing the execution, it will be stored in the disk level, right? And in the disk level, and the next RTD will take the output from the disk as input.
So automatically it stores either in the memory. If the memory is full or busy, then it will push to the...
No, I'll be discussing about the persist options.
Okay.
Persist options are there. I'll be discussing one by one persist option, memory and disk, and disk.
So, sir, when you say persist RDD, what does it mean exactly? Like, is it like moving the data from disk to RAM, or?
Persisting an RTD means making the RTD available in the RAM.
Okay.
Whenever the next RTD is ready also, it won't be removed from the RAM. Why you persist an RTD means, if that RTD is available in the RAM, it can give output. It can give its output to many other flows. Generally, which RTD you will persist? Anyone? Generally, which RTD you will be persisting? The RTD whose output is used by many flows. That RTD,
to reuse the result.
So that output will be reused by the many other flows. If we persist, it will be available. Otherwise, it will be removed whenever its next RTD is ready.
Is it similar to a table, sir? When RD is it like because I know the data frame. Is it different from the data frame?
Data frames, a structured RTD we call like a data frame. Next we'll be discussing data frames, right? RTD which has got a structured RTD A RTD with schema we call a data frame. Okay.
So, in which situations we need to persist the RDD? If you give some example.
See, in which situation you persist in RTD means?
Yeah.
R1, R2, RTD2, RTD3, 50 RTDs are there. 50th RTD output, okay, this is one flow. R51 up to R60. This is R61 up to R70. This is R71 up to R80. First time, this is your flow R12 in this way. This is your flow 1. This is your flow 1. Flow 1, entire thing it executes from R1 to R60, it executes. R1 to R60 after executing, okay, R1 to R60. After executing the entire flow, how many RTDs in the RAM? After execution finished, how many RTDs will be available in the RAM? Hello?
Zero.
Zero, right? No RTDs. Once the execution completed, the last RTD also removed. Second time, again, if you want to execute this flow, you need to start from the beginning or not? Again, no RTD in the RAM. When R1, when R2 is ready, R1 removed. When R3 is ready, R2 removed. When R4 removed, R3 removed. Next, second flow, again, no RTD in the RAM, third one. So what happens in all the three flows, even though the first 50 steps are common, still you are re-executing from the beginning. First time flow 1 executed. To execute flow 2, again, why are you executing the first 50 steps? Already executed in flow 1, right? That output you reuse. To reuse that output, this R50 should be available in the RAM, right? To reuse this R50 output, this flow 2 wants to use that R50 output and just only this is the float I want to execute. For that, RTD gets removed automatically. Yes. So we need to, we can make it available in the RAM by saying R50 dot persist. If I say R50 dot persist means whenever R51 ready, R50 won't be removed. Once this total execution finished, R50 in the RAM. Whenever you are executing the second flow, when R50 is available, right? Directly take its output as input by R51. This is your flow for a flow 2. R50 to 50 steps decreased, right? Hello? Understood? Manish Kumar.
Yes. Sir. Yeah.
So 50
Sir,
steps.
there's one more question. Yeah.
No, let me complete the entire process.
Yes, sir.
R50 dot persist means understood that what is the advantage of persist here? Everyone. If it is not persisted, you need to go again, second flow also go execute from the starting. The drawback of map reduce is transformations cannot be reused. Here the advantage of Spark, transformations can be reused. The already persisted RTD's output you can reuse. In flow 3 also, no need to execute from the starting. R52, this one, this is the flow. Means whenever this persisted means it will be available in the RAM. In flow 1, which RTD in the RAM? Once the flow 2 is executed, which RTD in the RAM? How many RTDs in the RAM? Flow
Only
2,
one RTD, right?
R50 will be remains in the RAM. Now, whenever I trigger this flow 3, the flow execution will start from R50 to R8. It won't re-execute from the beginning.
Exactly, yeah.
Understood why we need to persist in RTD, how to persist in RTD, what happens if we persist in RTD, what is the advantage of persistence? Hello.
Yes, sir. Why do we need to remove from the RDD from the RAM? Because why can't we keep all the RDD into the RAM? So here is it memory consumptions or what?
See, for example, in your phone,
Yeah.
your phone has got 2 GB memory, assume 2 GB. Daily, okay, for example, yesterday 1 GB data you got. Okay, today you got 1 GB data. Tomorrow you will get 1 GB means will it accommodate that data? Hello. Already
No, I think
yesterday
yeah.
and today 2 GB you got 2 GB full now. Tomorrow 1 GB data is coming means will the data get stored?
No.
So first RTD1 is a it's a bigger data set, huge data set, RTD1 itself. RTD1 itself is a bigger data set, right? If all the RAMs, it is occupying all the RAMs, most of the RAMs. It is divided into partitions and distributed across multiple RAMs of multiple systems. Do you think all these 80 RTDs will be at a time they will be loaded into the RAM? Think this size is 2 TB size or 1 TB. Do you think maintaining 1 TB RAM is a bigger task actually? Maintaining 1 TB RAM for a single RTD itself, it's very difficult. If we load all these RTDs, there won't be that much of RAM capacity. So that's why what is the full form of RTD? A resilient distributed data set. So whenever this R1 output is collected, when R2 is ready and computed, R1 will be removed because two RTDs R1 and R2 to accommodate this much of RAM, that much of RAM can't be maintained. All the RTDs can't be loaded at a time. RTD by RTD. That's the reason RTD by RTD it will be loaded. So all the RTDs, multiple RTDs you cannot load. When R2 is ready, R1 gets removed automatically when it's R2 computation finished. When R3 computation finished, R2 gets removed from the RAM. There is no necessity. I collected the output from R2, right? Now what is the use of R2? It will be removed from the RAM. Yes. For example, if they are not getting removed from the RAM, first 5 RTDs, assume that it has accommodated 5 RTDs. To accommodate the 6th RTD, there won't be any space in the RAM to process. And the advantage of Spark is in-memory computation. You want that computation to be within the memory level. Again, if you go to the disk level, right? Again, it's a drawback. In-memory computation we see in Spark, right? Yes. Understood, everyone? Any query in this? Hello?
Yes, it's clear. I think so. Yeah.
Why we are processing artery again and again? Only once we will process it, and immediately its output will be collected by performing some other, right? So yes, I'll show you, right, with multiple examples as we are removing old RTD. Yes. Okay. Understood this, right? Why we need to persist in RTD? Yes. Okay. 3 ways to unpersist. Directly RTD.unpersist. RTD.unpersist happens immediately. Whenever you say RTD.unpersist, immediately the RTD gets removed from the RAM. I got 2 queries here. RTD.unpersist means immediately it gets unpersisted, but RTD.persist won't happen immediately. Why? RTD.unpersist happens immediately. RTD.persist won't happen immediately. See, very simple logic, right? You are saying R1, RTD1, R2, R3. R4, R5 in this way. If you want to persist this R4, whenever you say R4 dot persist, whenever you say R4 dot persist, immediately it will be persisted. Without loading R1, R2, without loading R1, R2, R3. A question, if they ask query like, when a RTD will be persisted, I will say R4 dot persist, means when it will be persisted, means when R4 is first time loaded into RAM, it will be persisted. Once R1 loading finished, R2 loading finished, R3. Now when R4 is loading, when R4 loaded, it will be persisted. Until then, R4 won't be persisted. If you want to say R50 dot persist, R50 dot persist, it won't happen immediately. First 50 RTDs, before that 49 RTDs to be loaded into RAM. Then when R50 loaded, then it will be persisted.
Then it means all the R50, R49's RDD is still available into the RAM, right? If you persist R50.
Or for all the 49 won't be available. Only R49 output will be collected. When R50 is computed and executed, R49 gets removed. Only R49 will be there. R49 output, all R49 and R50. Once R49 output collected and computed, R49 removed, R50 will be the RAM. Understood? When RTD will be persisted,
Okay.
means when it first time it is loaded into the RAM, will be persisted. When, for example, execution finished, I want to unpersist R5, R4, I want to unpersist, R4 dot unpersist, you say. Immediately this R4 will be unpersisted. Now only R4 only available in the RAM. Immediately it will be unpersisted, right? Hello? Once the execution completed, only R4 only available. Immediately R4 will be unpersisted, removed from the RAM. So unpersist happens immediately, but persist won't happen immediately. I'll show you some data flows. 1 second.
So if you do the R4 dot persist, it means R1 is loading and then unpersisted. R2 is loading, then unpersisted, and finally the R3 is persisted and unloaded, right? And then finally the R4 it will be persist. Like this, you mean?
Persisting is different.
Yeah.
You don't, if you're not giving persist also, this entire flow will execute. It's not compulsory, you need to persist it. If you're not persisting also, just if you perform action on this R5, when you perform action, then it will execute from the root RTD to this end and gives the output. But if any flow, what is the advantage we get if you persist R3 dot persist means, if this R3 output is used by many flows, so make this R3 available in the RAM. Why? So that it can give output this flow 1, flow 2, flow 3, flow 4. If it is not available, the every flow need to start from the beginning. Good query, right? ARPAN. If I'm persisting, we don't have enough RAM, then okay, you have persisted R3. But when R3 is persisted, already the other flow data flows are executing, they are filled with other RAMs, sorry, other RTDs. Then there is no enough space for R3 to be persisted. In such case, persist options are there. While persisting, right? RTD dot persist, within the bracket, you will be specifying memory means only in memory. If memory not available, your execution fails. If you give disk, it will be only in disk, it will be. Memory and disk option is there. If memory not available in disk, instead of making the execution to fail, at least persist in disk and process it. Yes. there are some rules to be followed. There are some rules to be followed in the persistence, right? There are some rules to be followed in persistence. There are some persistence rules, and there are some persistence options are there. I'll be just show you multiple examples on this persistence. But before that, what is lazy evolution in Spark? Executing the data flow on demand. Executing the data flow on demand by performing an action. So what all we discussed, right? The steps in RTD computation. Steps in RTD computation. First one is initially all the RTDs are declared. Just now I said, right? They are declared like this. In this way, R1, R2, R3, R4, R5. Just they are declared.
I think unpersisted, I think you have written some more points actually when session is closed or that.
Three ways to unpersist, right? RTD dot unpersist one way. When session is closed, it will be unpersisted. When server shutdowns, it will be unpersisted. Whatever RTD in the RAM, they will get unpersisted, removed from the RAM.
When we can close the session, actually, we have to manually close or what?
No. Whenever the session is closed, Spark session is there, right? Whenever it is closed, that RTD, and whenever the server shutdowns anytime, then it will be unpersisted. Otherwise, generally we will do, if it's not required, we'll say RTD dot unpersist. In the program code only, we'll just keep it. Then at the last, it will be unpersisting it, so that once the execution completes, remove that also, if other flows doesn't want to execute it. So steps one by one step, right? Initially, all the RTDs are declared, they are not stored anywhere. We load them on demand by performing action. This type of evolution is called lazy evolution. When action is performed, flow execution will start from its root RTD to available RTD. When action is performed. And during flow execution, each RTD partition will be loaded into RAM of cluster machines and computed RAM. See, you have got multiple machines which has got RAMs, that RTDs will be distributed and they are computed. Once RTD computation is completed, it waits for its next RTD of the flow. If next RTD is ready, previous RTD will be removed from the RAM. This process continues till the action is completed. When action is performed, all RTDs are stored and computed at Spark side, that is at Spark cluster machines. But the final result will be produced, which is produced, is stored in the client machine. Client machine means the machine from where you are submitting the job. During flow execution, the RTD which is commonly used by many flows will be persisted. Persisting means making the RTD available in the RAM. So the other flows can reuse the executed transformation. Finally, the RTD stored in the RAM will be unpersisted when session is closed or when server shutdowns are forcefully, we can unpersist. So
can you explain the step number 5? Could you explain step number 5?
Step
5. Yeah.
Which step?
5.
5. When action is performed, right? Whenever action is performed, RTD dot collect action is performed. One by one RTD, first RTD one gets loaded. You will get the output. That output is taken and you are performing some transformation. After that, RTD2 you got. RTD by RTD will be loaded and computed, I'm saying. RTD by RTD, they get loaded and stay. one action is performed, all RTDs are stored and computed at Spark side.
Okay.
All RTDs are stored one by one. If you feel confused, and computed at Spark side. That is Spark cluster, that is in Spark cluster machines. Understood? Spark cluster machines. But the final result output you get, right? Final output means this RES. This RES is taken by the client, Total processing happens in the Spark cluster machines. Final output is collected by the client machine from where you are submitting the job. Yeah, at the end of the class, I'll forward this document in the chart panel. In this chart only, Zoom chart only, I'll forward. During the flow execution, the RTD which is commonly used by many. Okay, this is understood, right? I'll come back to this persistence with multiple examples, but there is a or so you might be asking multiple questions like when it is running on multiple machines, suddenly if a particular machine is down, then there is a loss, right? So for that the Pyspark has got powerful fault tolerant model. Fault tolerant. I'll come back to this persistence, but before that, fault tolerant in Pyspark. While executing the RTDs. Case 1 you observe. When current RTD is down. Observe when the current RTD is down. When the current RTD is down means just observe this diagram once. R1. This is RTD1, R1. R1 has got a P1 partition, P2 partition, P3. R1 has got 3 partition. This R1 output. R1 output is taken as input. Is taken as input by R2. R1 output is taken as input by R2. P1, P2, P3. Yeah, 3 partitions. This R2 we call it as current RTD. R2 we call it as current RTD. This R1 we call it like previous RTD. What is it? When the current RTD is down. Observe carefully when this R2 is. I'm writing clearly during the execution of current RTD. During the execution of current RTD, R2, RTD2. During the execution of current RTD, R2. If anyone of the partition, if any one of the partition if any one of the during the execution of current order, if any one of the partition machine is down. Think that this is P1 is stored in one machine, P2 in one machine, P3, three systems they are storing. For example, this P2 machine is down while during the execution of the current RTD R2. Once this total computation is finished, R1 will be removed. Observe here, once the total computation of R2 finished, then only R1 removed. But while computing R2, any one of the partition machine P2 machine is down, then P2 partition down means P2 data is lost. If you continue further, then very simple logic. All the current RTD partitions P1, P2, P3 will be deallocated from the RAMs of that particular machines. They'll be deallocated everything, cleared from the RAM and reinitiated and reloads into other slaves other than the current systems, right? By taking the input from R1, where R1 is available still. So it will deallocate, again takes the input from R1 and loads into three different machines other than the machines, right? Understood now? Still, during the execution, if any one of the partition machine is down, then try to say, yes, everyone try to say, then all the current RTD partitions P1, P2, P3 of R2 will be deallocated. Deallocated means cleared from RAM. And reinitiated or reloaded in other slaves by taking input, okay, and reinitiated into other slaves by taking input from its previous RTD, that is what? R1. The three partitions are stored. The three partitions are stored in three different machines. Excluding the machine which is down, right? Excluding the machine which is down. Understood this first one, case one? Hello? But why it's deallocating all the current parts as here one machine is down, but we are removing? Yes. How can you get then P2 part if P2 system 1, system 2, system 3, three systems storing this three partition? This machine is system 2 is down, that partition data is lost. How can you get that P2 partition data again? How can you get the P2 partition data means? Again, the output, whatever you are getting from R1, again you recollect it first. You recollect it and store in different machines. If you are not clearing this means, again, it's a waste of memory, right? First clear this and again collect the output, again store this output, P1, P2, P3 again. Only P2 you cannot get it from R1. Only P2 you cannot get it from R1. Only particular partition you cannot get it. Total output okay, you can get it. R1 dot filter, you will get the output as R2. That R2 is distributed across. Observe here, R1 dot, if you're performing some filter, then you will get R2. That R2 partitions P1, P2, P3 will be R1 output. Only
Sir, is there a resource manager or someone who manages this machine allocation or this memory allocation and deallocation?
yes, resource manager is there.
That belongs to Spark or that belongs to the SDFS
Hadoop.
Hadoop?
Yes, Hadoop.
Hadoop. Okay.
This total everything runs on the yarn only, right?
Yeah.
These three partitions, understood, right? So we cannot get a particular partition. Entire R1 output you can get it, but a part of R1 output you cannot get it. I want only a part of R1 output you cannot get. Entire R1 output you can collect it, but only a part of it can't be collected. R2 collecting the output of R1, entire output it can collect. Only a part of its output you cannot collect it. So that's why clear it again, reallocate it. Okay, now case 2, observe this case 2, right? Can we expect this? Okay, case 2 you see. Case 2. When previous RTD is down. When previous RTD is down. Observe here. This is R1. From R1, its output you are getting to R2. R2 from R2 to R3. R3. When previous RTD is down, means previous means R3 means current. This R2 means previous. R2 means previous, R3 means current. Assume this R1 only S1 stored in S system 1. This is system 2. This is system 3. This is down. This is down. Try to answer everyone. When in the first example, this current RTD down means previous RTD available. Okay. You can take the output of it and again recompute it. But while R3 taking input from R2, while R3 taking input from R2, suddenly R2 failed. While R3 taking the input from R2, suddenly R2 failed. R2 failed means its partition machines are down. Then R2, can it collect the output from R1 again? Can it recompute? Try to answer. Can R2 recompute and again can it collect input from output of R1 and recompute?
No.
No, sir. R1 not available.
R1 not available, right? When R3 is computing, R2 only available. When R2 ready and computation finished of R2, R1 removed from the RAM, not available in RAM. R1 not available. R2 is previous. Now try to say, yes, try to say what is the process here? R3. During the execution of control to there. While taking input from R2, while taking input from R2. If
in case one, hello. Yeah, in case one, when we have a three partition, correct? P1, P2, P3, all are the three different machines, correct? And we are processing those data in three different machines. Am I right?
Yes.
P1, P2, P3, these three data is getting processed in the three different machines, correct? One machine got down. Let's say that P2 got down.
Yes.
Okay.
If one machine.
So we know that this machine got down and one machine got down, correct? And R1 also have a three partition, P1, P2, P3, correct? And all running in the three different machines. R1 also, correct? P1, P2, P3, all are running in three different machines, correct? And three different machines we have a output in R1, correct? Which we are sending to the R2, correct? Yes. Now P2 machine has got down, okay? So we know that this P2 machine got down, correct? And we know that P2 machine using the partition P2 means M2 machine, let's say that got down, and we are using the P2 partition, correct? And P2 partition data is available in the different machine in R1.
See here, one second.
So directly cannot be sent
one second. One second.
I think P1, P2, P3 of R1 are different for R2, P1, P2, P3.
If there are 50 systems are there, R1 is stored in 3 systems in that 50 systems. R1 output is stored in 3 systems.
Okay.
R2.
Okay. Now I got the 52 systems data we are storing to the three systems. Is it correct?
So, for example, any RTD is there means how many partitions are there? 10 partitions. See, 10 partitions are there. RTD is there. RTD is stored across 10 systems out of 50 systems available. In which 10 systems available, you cannot say. You cannot, which 10 systems, that entire information will be available with the master node. That things will be available with the
master node know that.
Yes, that we call as
but
name
master
node.
node know that.
That it knows. Yes, it knows that.
Yeah, that name node knows.
So internally, it is not. It's not.
So name node. Please go ahead.
So whenever you want to see the partitions data, you can see the partitions. If 10 partitions, 10 part files you will get. Part files. Part 1, part 2, part 3, part 4. 10 part files you get. Part 1 output you can see. But in which system it was stored, that information won't be available. So whenever it's up to that name node, if it's up to that, right, in which system it is going to store, that entire thing we are now very concerned, right, that that dividing the partitions and distributing everything, taking care internally, right, we are not going to do anything on it. And R2, yes, there is no way. Okay.
Yeah.
So one thing, you are saying that if P2 is done, why won't you collect only P2 data from R1? Why again removing all the partitions?
Yes.
How can you collect P2 data from R1? How can you collect?
Node manager know that P2 machine got failed. Node manager know that P2 machine got failed. It has information about the R1 also, correct? Where R1 P2 data is there, result set is there, correct? R1 whatever process that that which machine have that results. Node manager have this information. Can we use that information and send only P2 data?
P1, P2, P3. So no. Once again, you need to collect the output from R1. You cannot collect a part of output from a particular RTD. Only the entire RTD only you need to entire output only you can collect. You can okay.
Correct. They have designed in such way. Correct. I'm agree with you.
So
but
here,
why they didn't use this concept from node manager get that where is P2 data in R1 and send only that one.
Sir, R2 partition 2 value is different from R2 P2 partition, right? Both are different.
Yes.
so see, first one R1
Correct.
is see, one second. Please be in mute. I'm getting songs from some songs. Okay, fine. R1, R2, R3 is there. From R1, R2 got created. From R2, R3 will be created. From R3, R4 will be created. Do you think in all the RTTs the same number of partitions? In all the RTTs, do you
No.
think the same number of partitions will be there?
No.
No, right?
No, it will not.
See, from R1, filter only males. Think that males and female employees are there. Out of 10 lakhs, 5 lakhs males, 5 lakhs females. In R2, only males will be there, right? Only males means 50% of data filtered. Again, on R2, again, if you perform filter only the employees, male employees who belongs to Hyderabad city, that is R3. In R3, you will see what? Only Hyderabad city employees of males. Still, it is got decreased, data is decreased. Do you think same 3 partitions will be available for R3? No, right? Hello?
No, you are right. Yeah, in this case, you are correct. Yeah.
Okay.
Because it may be that male data we are getting from the P1 partition, P2 partition, P3
from
partition.
R2 to R3, you are getting what? R2 to R3, filter only the Hyderabad city. In R2, you have got 3 partitions. In R3, you got 2 partitions. Right?
Correct. Yeah.
Understood, right?
Yeah, but it's still not 100%.
But
I need to think about it.
In R3, you said there are 2 partitions. Do you think the P2 partition data of R3 and R2 P2 partition data are same? Hello?
No.
Yes, sir. That is what we are thinking. I mean, R2.P2 equal to R1.P2 equal to R2.P2. That's what we are thinking. R2.P2 fail, then we can collect from R1.P2. That's why we are thinking. The names are same.
No. 1 second. R2 on R2, if you are performing some transformation like filtering, right? R3 got created. In R3, there is only 2 partitions. In R2, you got 3 partitions. Do you think in R3 P2 and R2 P2 data will be same? No, right?
No.
Yeah, no, right.
No, right?
Because you are doing filter, right? Yeah.
That filtered. In this P2 total all cities data available, but in R3 P2 only Hyderabad city data only available. Understand, right? That's what. And one more thing. Please be in mute. You can ask the query and you can go into mute if you have got some background noise. For example, there are 2 types of narrow transformation, wide transformation. There are 2 types of transformation. Later I'll be discussing about those narrow transformation, wide transformations. Narrow transformation means no shuffling of data. No shuffling of data. Same from P2 to P2, P1 to P1, data will be moving. There are 2 types of transformation. Narrow transformation, wide transformation. Narrow transformation means from this P1 R2 P1 to R3 P1 data goes. From P1 to P1, P2 to P2, P3 to P2. That is what narrow transformation. Right? But wide transformation.
Even in narrow transformation
Let me complete. Wide transformation. What do you mean by wide transformation? From P1, it goes to all partitions. From P1, it goes to P2, P3, P1 of R3. From this R2, wide transformation means from this P1, the data is shuffled to multiple partitions of R3. That is wide transformation. From P2, P3. That is wide transformation. Data is shuffled across. It is wide trans. If data is not shuffled as it is moving from R1 to R2. Then it is narrow transformation, right? So, but here, whenever any machine goes down in a particular RTD, that partition data is lost. That P2 partition data is lost. So in such case, all the partitions will be cleared from the RAM. Because on R2, on R2, I cannot perform any transformation. Some data is missing, right? So if you perform anything, right, with this data is missing on P1 and P3 data only, any filtering or any transformation you're performing will be performed. So you will be losing some data here. So what you do, first clear all this. Again, take this entire output, again store it. On this, you perform transformation again. So the only thing is, here, if any P2 machine is down, only P1 data, P3, but P2, some lakhs of data is lakhs of records are missing of P2. So how can I get this P2 again? I need to perform some transformations on all entire data dot filter, P1, P2, P3 partition data dot filter, or transformation or merging or sorting on these three. But if this machine is down, then some data, some lakhs of records are missing. So if it is missing, I cannot go further. So what I want the full data. So what you will do, this partial data totally will clear it from the RAM. You clear it from the RAM. And again collect R1 output, P1, P2, P3 output. Again on this, you perform operation. You're getting back when R1 is available in the RAM, get its output again. But as you are saying, I will get only P1 from this R1, that's not possible. You cannot, R1 cannot output, R1 cannot output only a part of it and sending that to this R2 is not possible. Total output will be collected by R2, then R2 partitions will be distributed across multiple RAMs, right? But only a particular part, no.
But I'm agree on the wide transformation, correct? But if they can identify that it's a narrow transformation or wide transformation, if it is a narrow transformation, then they can do it, correct? Wide transformation, I'm agree, they can't do it.
Forget about that narrow and wide. Wide transformation, narrow transformations means there also the entire output only you will be getting, not a part of the output. Entire R1 output only you will be getting to R2. But whether to the same partition or different partition. 1 second. The entire output you will be getting to R2, but while getting, they may go to the same partition or they go to different partitions. Here, if you got 1 lakh records are coming, in the narrow transformation or wide transformation, 1 lakh records only will be coming as the output. That 1 lakh records, they will go to the same partitions as are in this way, or they go in different partitions. I am grouping based on city. All Pune cities into P1, all Hyderabad cities into P2, all Mumbai into P3, if I perform grouping based on city. But you are getting 1 lakh records, right? Not a part of the R1 output, right? Whether it is a wide transformation or narrow transformation, you will be getting the output, whatever is getting the output, the volume of the output will be the same. But whether it is going to the same P1 to P1, P2 to P2, P3 to P3, that is narrow. Wide transformation means from P1, in P1, all cities data is available. Some part of P1 going to P1, Hyderabad. Some part of P1 going to P2, that is Mumbai. Some part of P1 going to this Chennai in this way. That is distribute. That is what shuffled.
Yeah, but if you think
no,
yeah,
what
if you think that I'm just converting uppercase P1, P2, P3. then R1 have same partition, R2 also have same partition, same data will go there.
That is narrow
Correct? In
transformation.
that case, if we,
That is narrow
okay,
transformation.
whatever, I don't know that. Okay. Yeah, narrow transformation, let's take that. And in that case, if P2 got down, then we can, at least we can do it. Correct? Because just I did converting all the records city to the uppercase. Correct? So same number of records, same number of partition will be there in R2. Are you getting my point?
R1 output, if it is 1 lakh records, 1 lakh records only you need to get it. P2 partition like 20,000 records, you cannot get it from R1, I'm saying.
Okay, move on.
You are saying P2.
Only in one, yeah, only one case I can see that. If we are just doing the transformation, let's take that the uppercase, I'm converting that all the records. So same number of partition, same number of records will go to R2, same number of partition will go to R2. In that case, at least we can implement this thing, but I don't know why they didn't get that.
See, don't go into imagination.
Why transformation? I got that. Where?
One second. Okay. Okay. Try to collect only P2 partition from R1. In which system it is stored? P2 partition, in which RAM it is stored, in which system it is stored? How will you collect only P2 partition in which systems? If you have got some 50 systems, in which system the P2 partition data? It doesn't mean that in S2 system only it is stored. Okay.
So, sir, we cannot query particular partition of RDD, right?
You cannot query a particular partition and RDD. Yes, no. See, whenever you want to perform any action or transformation, you will say rtd.action, rtd.collect, you say. All the inbuilt transformation, rtd.count, you say. rtd.take, you will say. rtd.map, you say. But these actions and transformations will be applied on RTD only, not on the partitions. Yes.
Okay, so once we get the data in a Python data frame, then we can query, right?
On the data frame, you can perform querying. Querying can be done.
Okay.
So querying can be done, right? On this R1, R2. Once the data frame you got, okay, you can perform any SQL kind of querying can be done.
Okay.
Here, whenever there is a data loss, right? Compulsory, I'm saying about the storage here, storage and processing here. But
so one more question, sir, here. So you say like P2 partition P2 node is down, then this situation will automatically will be taken care, or we have to restart that
one
particular
thing. 1 second, one thing, right? Whenever in Spark, Spark has got powerful fault tolerance model. Here, whenever particular system goes down, automatically we are not going to clear. Automatically the RAM of it gets cleared. It gets cleared and this output will be collected and will stored again on different machines. That in which system that is not, we are not going to store in a particular system that it will store, right? In some systems. That is also there is some priority and there are some process for it. Right?
Okay.
Automatically, whenever this P2 means think that some system 7, this P2 is stored. Other than that system 7, next it will use any other system for storing these 3 partitions. After collecting, it will store. First, it has our system 6, system 7, system 8. These 3 partitions are stored in S6, S7, S8. Once again, the output will be collected and it will store in different systems. Some say like S12, S13, S14. Other than the system which is down, right? So here, how the Spark computation, how the Spark fault tolerance model is going to work means anytime, if this kind of, again, getting this lost partition only in Spark, you can see in any other, right? You cannot see that. It is automatically, it has got the capability of recomputing and getting back the lost partition. only that Spark has the capability of, right, of getting the lost partition. First, during this process, it will deallocate, it will clear all these partitions, again it will collect, and again it will going to store across multiple RAMs of multiple slaves R2. But here you didn't still we are in there. I discussed 5 cases, right? If a persisted RTD machine is down, if a RTD which is persisted in the RAM, that machine is down, then means how Spark computation is going to work, you need to understand how the Spark is how computing the things. If a particular machine is down, if a persisted RTD machine is down, yes, and previous RTD machine is down, if the current RTD machine is down, yes, in this way, how the Spark is computing, we need to understand it. During the, see here, in this case 2, when the previous RTD machine is down, right? P1, P2, P3 is transform data based on O2. R1 is your data set. On this R1, if you have performed some operation, R2 got created. R2 might have same number of partitions of R1, or it may have less than or equal to. Yes. It can have the records less than or equal to R1. It doesn't mean that it will have the same number of partitions. It will have. So during execution of current RTD R3, while taking input from R2, if R2 failed, then how? If here R1 is stored across multiple systems, just as I said S1 here, for example, R2 also stored across multiple systems, R3 also. Here R2 failed means any one system of R2 failed. If R2 failed, then can you load R2 by taking the output from R1?
No.
No.
Here R2 can't be reloaded. R2 can't be reloaded. Or reinitiated. R2 can't be reloaded or reinitiated in other machines. Yes, because cannot be reloaded or reinitiated in other machines because R2 input is R1. Which is not available in RAM. Which is not available in RAM. So what happens? So the process, so not available in the RAM. So we cannot get the R2 partition data from R1. R1 is not available. So the process. So here nothing doing, that the process start from the beginning. The process should start from the beginning or from persisted RTD or from persisted RTD. The process should start from beginning or from the persisted RTD.
If
So
RTD is not persisted, then again from the beginning itself, right?
So the process should start from the beginning. If no RTD is persisted, if no RTD is available in the RAM, the process should start from the beginning. Again, R1 loading, next its output taken by R2 loading, next R3 loading, one by one again. We cannot, means here, one way this process is good, one way this is bad. One way this is good, one way this is bad. What is that good and what is the bad here?
If it is persisted, then I think it's good. Otherwise,
Forget about the persistence here. No RTD is persisted here. Did I
So
write R1
bad thing is
R2?
we need to reprocess again whole thing.
Oh, yes. So here no RTD is persisted here. I didn't write anything with no RTD because it's a small flow. One way this is good means that we made the flow to execute. The execution is, we made the flow to be executed. Execution is not stopped here. One way it is bad because while R3 taking input from R2 means R1, R2 computed, but when R3 is computing while taking input from R2, R2 failed. Means already R1 and R2 got computed already. They already got processed. Again, we are reprocessing R1 and R2. That is one way, it is bad. Again, we are re-executing R1 and R2. Again, we are reprocessing R1 and R2. That is what, right? That is, but anyhow, we are making the flow to execute. So the total flow executes R1, R2, and R3. Now,
Is
observe.
there any way to go ahead? Sorry.
Yeah, anyway.
Is there any way to avoid the reprocess?
In this case, whenever, in this case, right, there is no other possibility because the previous RTD is not available. Whenever the current RTD is computing, the previous RTD fails means compulsory it has to start from the beginning, or if any RTD is persisted available in the RAM, from there it has to come. Right? Anytime while computing the current RTD down means no problem. Case 1. Current RTD down means no problem. Case 1. The previous RTD available still, but while computing the current RTD, previous RTD machine is down means it should start from the beginning, or if any RTD available in the RAM, from there it has to come. Case 3, right? Case 3. If a persisted RTD machine, if a persisted RTD machine is down, if a persisted RTD machine is down, right? For example, see this flow. R1, R2, R3, R4, R5. Just S1. Just I'm mentioning only one system, but stored across multiple systems. S2, S3, S4, S5. Think only one partition only available. In R1, only one partition stored in S1. In each one, only one part assumed. R3 persisted. R3 persisted. If suddenly S3 is down, if suddenly S3 is down, here how this Spark computation is, right? If suddenly if S3 is down, then observe the flow will be re-executed from the available source. From the available source means either it can be from the RTD which is persisted or from the beginning automatically. See, if S3 suddenly if S3 is down, the flow will be re-executed from the persisted RTD or available RTD or from the beginning. Till R3, the flow will execute. Till R3, the flow will be executed without performing action. Automatically, the flow will be executed without performing. Generally, to execute the flow, action has to be performed. But here, whenever persisted RTD is down, automatically the flow executes from R1 to R3. And R3 will be re-persisted automatically. And R3 gets re-persisted automatically. Understand this. R3 is stored in S3 and persisted. If suddenly S3 is down, then try to say, then what we, then the flow will be re-executed. The flow will be re-executed from the available flow will be re-executed from the available source. Available source means that is from persisted RTD or from beginning. From beginning, right? Automatically.
So here persisted means from R3, right?
R3 is persisted. So this is the flow. In that R3 got persisted. But suddenly this machine is down, S3 machine is down. Suddenly it is down means automatically it comes from R2 to R3 and re-persist it automatically.
So whether R1, R2 persisted or unpersisted doesn't matter, right?
Yes. From persisted RTD or from beginning. From beginning.
Sir, one question here. Can it be persist
on.
more than one RDD?
Yes, it's a good query. Yes, in the case 4, in the case 5, I will discuss, right? Persist from beginning till R3. We can persist, yes. Or from, if you have got good RAM capacity, then we can persist multiple RTDs.
So if we persist multiple RDD, then in this case, what will be happen actually? If R1 is also persisted, suppose that, and R3 is also persisted. So all the flow will be happen automatically.
If R1 is persisted already means R1 is available in the RAM, so no need to execute R1 again. R1 output directly you collect it, and R2 you compute it. R3 again compute it. So if R1 is already persisted means R1 is available in the RAM.
So last persisted, RDD they can take it. Yeah.
Yes, that's why I'm saying that the flow will be re-executed from the available source, that is from the persisted RTD onwards only. If R2 is persisted, from R2 itself only it will compute. Again, this R1, R2, it won't recompute it. If R2 is persisted, R3 is persisted.
Sir, one question. So as you said that there is no action required to re-persist the R3 for an example. So yeah, saying that let's say there is process is going on where this persisted RTD is not used, and then so in that case, if the system goes down, the S3, so it will automatically re-persist it, calculate from R1, R2, and then R3.
So when that re-persisting happens means whenever a particular persisted machine is down only, it will be re-persisted.
Yes. So for an example, so there is one flow, R1, R2, R3, R4, R5. R3 is persisted. And again, there is another flow, let's say we have multiple persisted RDDs, and based on our demand, so we are reusing it. So now we are executing a flow where R3 is not being used in that, but we are using other persisted RDDs. And in that time, so if the system 3 goes down, so again, without any action, it will recalculate, recompute, and then persist R3 again.
Yes.
So in that case,
Compulsory when any RTD persisted machine is down means compulsory automatically the flow executions happen again it will repersist it.
so we need not to worry about it.
So when
So
this is when this automatically the flow execution happens means only for the persisted RTD only. And for if the previous if this current RTD machine is down also, it will take the output and computes, but it will only computes the previous and this only. But if there is a very big flow, that won't be. See, if our persisted RTD machine is down and if a normal RTD machine is down, see the difference. If R30 is there, means 29 steps are there before. R30 is persisted. If R30 is persisted means if that R30 machine is down, the flow will execute from R1 to R30 if no RTD available in the RAM in the middle. Automatically the flow executes from R1 to R3 and R3 will be repersisted. But if R3 is not persisted, it's a normal RTD. Do you think the flow executes from the start? No. Means yes. So in this case, repersisting is going to happen. One thing what you are going to observe is repersisting is going to happen. It is going to repersist. Okay. Then the flow will be re-executed from the available source from the persisted RTD or from beginning till R3 automatically without performance. See one thing. Okay. Before I'll make it. Whenever R1, R2, R3, R4. Whenever R4 machine is down, R4 input is R3. First it will check whether R3 available or not. If available, directly it takes its output and R4 computes. If R3, okay, next, for example, it keeps going like this, bottom to top. From where I need to start the flow. If R2 is persisted, the flow starts from R2 to R4. If R3 already available, from R3 to R4. If this is not available, yes, you need to know R4 input. If you want to compute a particular RTD, if any, first its input, it will, where it has to get its input, R3. If R3 available, okay. If R3 not available, again, from where R3 input is R2. R2 available means R2 to R3, R3 to R4 computes. If R2 also not available, R2 input is R1. If R1 available in the RAM, then don't execute R1. Directly take R1 output and compute R1 to R4. R1 also not available, then R1 input is file. From here onwards, come process R1, R2, R3, R4 and takes that R4. But if R1, R4 inputs are from where I need to start the flow, from R1 or from R2 or from R3, it depends upon the RTD availability in the RAM. Understanding, right? From where the flow has to be started if any partition machine is down means which RTD available in the RAM. From there onwards, if no RTD available in the RAM, start from the beginning. For R4 to compute, R3 available in the RAM, right? Directly R3 to R4. While computing R4, if R3 down means, from where you need to start? If R2 persisted, R2 available, from R2 you need to start. Not available, R1. R1 persisted, if it is available, start from R1. If nothing available, start from that first R1 also you compute. R2 again recompute it. R3 in this way. Yes, some queries were
When
asked.
you say RDD persist, is it the data in the RAM before applying the business or transformation logic of that particular RDD? Suppose RDD2 is persist here.
See
So
here,
RDD2, is it the complete data before applying the logic of that RDD2?
see R1, R2, R3, R99, 99, totally 99 steps. At R99, I'll say R3 dot persist. Will it be persisted? R1, R2, R3 up to R99. After R99 step, I'll say after that line, I'll say R3 dot persist. After first 99 lines afterwards, I'll say R3 dot persist. Will it be persisted? When a RTD is persisted, I said, when first time the RTD is loaded only, it will be persisted. Understand? Some query was asked, if I persist RTD by mistake, but I am not using that RTD, but I'm not using that persist RTD. See, if we are not using R3, then why to persist an RTD? So when you are going to persist an RTD means whenever multiple flows is using this R3 output only, you will persist it. Otherwise, you won't persist. You won't persist it. For example, R5 equal to R3 dot, R6 equal to R3 dot, R7 also equal to R3 dot. On R3 output, if I'm performing something, R5, R3 dot, R3 dot, R8 also R3 dot. Means all this they are using R3 output only, right? Then persist R3 so that if it is available, then all this will be getting the output of R3s. Then you persist, but none of them you're using this R3 output, only one R5 only using means no need to persist it. You can easily understand by writing your code only, you will come to know it's R3, should I persist or not? Yes, okay. Whatever, if human error also, it will be persisted. If a persistent RTD means it will be persisted, whether it is a, how come it will be, okay, by mistake, if you are persisting also, persist means it will be persisted. Be till R3 automatically without performing action. And R3 will be R3 will be repersisted, right? Yes. Understood this case three, right? So, okay. Some more cases are there, right? Some more cases on this RTD. This is fault tolerance and yes, we can persist two RTDs. In tomorrow's class, I'll be showing you, right? Two RTDs or multiple RTDs can be persisted. Okay. So I'll just keep these notes, see all that what was discussed, right? Persistence, how the steps in RTD computations, what is transformations actions, Spark advantages, Pyspark compared with other things, right? On the starting, the clear notes, what we have discussed, everything I'll be forwarding you. You can see in that Zoom chart now itself. Just give me 2 minutes. Just give me a minute. I'll be just forwarding the notes in the Zoom chat only. 1 second.
Thing like daily session, like what time it will start and what time it will end.
Tomorrow, say 1 second. Tomorrow, yes. Pyspark class 6:30 sharp it starts. 6:30 starts. Nearly it goes to up to 6:30 to 8:20, 8:30 it goes. Tomorrow,
This
that
weekend
tomorrow,
batch.
yes, weekend. It's a weekend batch only. It's a weekend batch. 2 hours on Saturday, 2 hours on Sunday. 6:30 to 8:30. So once we are start with it's a if once we start with the practical, I'll be just extending the session, right? I will be extending the session. So 6:30 to 8:30 is the timing. It is the 6:30 sharp it starts. Tomorrow also, right? Everyone. So still, if anyone have not got enrolled, so everyone try to get enrolled by tomorrow session. Tomorrow you will be getting a new link to your mail IDs. Today, whoever have joined, right? So check your mail IDs. Means you need to get enrolled. If anyone still have not got enrolled by getting enrolled, okay. See that payment process and procedure for Pyspark. Yes, get enrolled, and tomorrow a new link you will be getting to your mail IDs. So that link you follow, right? Everyone you will be getting a new link. If you have got already enrolled, means if a package Hadoop and Spark, and if anyone only for Pyspark, right? Only for Pyspark if you are preferring, you can see in the chart panel the payment process and procedure get enrolled, right? So anyhow, I'll be forwarding the notes, but the videos of this Pyspark, a WhatsApp group for Pyspark tomorrow will be created. A WhatsApp group will be created for the Pyspark, and to your Google Drives, the Pyspark videos will be getting notes every day, every like session by session, you'll be getting the notes, all those things once you get enrolled. Fine.
And the videos, how long it will be available in Google Drive?
So as for 6 months, 6 months, right?
6 months means like today onwards, right? Or the course completion.
Yes, from today. Means so whenever the batch start, once from today, right? 6 months it will be, yes.
And for Pyspark, do we need any prerequisites or Hadoop anything, or if you want to learn Pyspark?
Yes.
Sir, I was going to cover some part of Python also, right? Before explaining the code. Hello? Are you there?
Can you see in the chart right now? Pyspark notes is forwarded. Can you see in the chart now? Hello.
Yes, I can see.
Okay, fine. Tomorrow at 6:30, the session will be at 6:30 Pyspark, right? Yes, and the other people, right? Those who are attending Hadoop also, right? Those who are attending Hadoop, there will be a scoop class before it. Okay, fine.
5:30 tomorrow, right?
Yes, yes.
Okay.
So Pyspark class tomorrow sharp at 6:30 it starts. Okay, a new link. Check your mails. Fine. Okay. So I'm stopping for now. We'll continue tomorrow. So if anyone, if you're not enrolled, try to get enrolled, right? For getting the link. Fine.